Good morning, ladies. Forgive me for not being there. We're going to go ahead and get started on the lesson for today. We are just continuing on with polynomials and being able to today we're going to be doing some division with them and synthetic division, which is helpful to know when things are zeros specifically. So a zero, if we recall, is an x-intercept. It's also a solution, right? Or it's also called a root. But a zero is basically what makes the polynomial zero, right? So polynomial division, the remainder theorem, and the factor theorem. I actually eliminated the factor theorem from this lesson after I made the lesson and sent the lesson off to be printed for you. So dividing long division with polynomials isn't always the easiest thing. I'll probably ask you to do it once on an assessment, but furthermore, we are going to actually do synthetic division for the most part, the remainder of this lesson. But I got to show you how to do long division at least one time, and then you'll have, I believe, 2 on your homework for tonight. So we want to divide the following polynomials, again, using long division. If you remember long division, we put the stuff on top inside and the stuff on the bottom on the outside here. So if we set that up, that means that we, need to set up our little division guy. And we have 5x, let me decrease the size of this. 5x to the third minus 13x squared plus 10x minus 8. And then we have x minus 2 on the outside here. So it's like, how do I go about doing this? This is a little funky, right? I have to know, and when we talk about long division, we usually say, how many times does this go into the inside, right? Well, we don't know that specifically. We don't know how many times x minus 2 goes into this polynomial inside. But what we do is we use this leading coefficient of x, and we divide this x by this guy inside of here. So on the side here, I'm going to put 5x to the third divided by x. And what do we know that is? We know that that is 5x squared, right? So we're going to do 5x squared goes in, they're on top there. And if we recall, back in the day, long division, we do this 5x squared times this, but we're also going to have to do it times the negative 2. So if I were to take that away, and I'll do it in a different color, 5x squared times x is going to give us 5x to the third. I'm so used to having these blown up because we're in class, but it's but I also then have to do 5x squared times negative 2, which is negative 10x squared. Okay, so just like that. And then we have to divide, right? Subtract. So when we subtract, this minus sign gets distributed in to everything. So technically, it just changes the signs of everything following. So the negative 5x, or the 5x3 becomes negative, and the negative 10x squared becomes positive. So it's negative 5x cubed plus 10 now. And then we add those together, right? So I was going to try to so 5x cubed minus 5x cubed, that cancels. That's the whole reason why we put 5x squared at the top there. Then we have negative 13x squared plus 10x squared. That is negative 3x squared. And then these things just drop down. Plus 10x minus 8. So we got to keep going. So then we ask ourselves, how many times does this x squared, this x, go into this guy? So I come over to the side here, and I have negative 3x squared divided by x. Well, that's negative 3x. Okay, so I'm going to go back here. I'm going to put negative 3x up at the top. I have all these colors, and I'm just trying to erase them again. So now negative 3x times x, which would be negative 3x squared. And then we have negative 3x times negative 2, which is positive 6x. And then we subtract. So as I said before, the signs just change. So let me change this to a different color here. I had somebody messing with my iPad. It changed all my colors. So this changes to a positive, and then this changes to a negative. They just switch signs because we're subtracting that polynomial from this polynomial up here. So negative 3x squared plus 3x squared, that's why that cancels out. And then we're left with 10x minus 6x, that's a 4x. And then we drop down the minus 8. So I might need some space in a little bit. Okay, so our last but not least, we need this x squared to go into this 4x. So I can come over to the side here and do 4x divided by x, which is 4, positive 4. So the plus 4 goes there, and then I have to multiply it out. Excuse me. So I have 4 times x, which is 4x, and then 4 times negative 2 is negative 8. Okay, and then I need to switch all the signs. So I would make this a negative, and then this becomes a positive. I'll change that. So switch the sign here, and then this becomes a positive, which is really nice. I didn't notice, I didn't do this problem before, but we'll talk in just a second. So that cancels, and this also cancels. So we really have no remainder, which is kind of nice. We'll talk about the remainder down the line and what that means. And if it is a remainder, that actually has something that it applies to the actual polynomial. So for your homework tonight, though, they have in, if there is a remainder, so let's say there is a remainder, they have it as, write it as a certain way. So it's that they have it as like x minus 2, which is the denominator there, times what we got up here, which is 5x squared minus 3x plus 4 equals 0. And if the 0 was really a 5 or a negative 17 or a 20, we would put that right here. And then that would be our answer. Just this. I don't like that notation, but when I was looking and making your homework, I said, well, I'm going to have to show them that that's what the computer wants. Typically, what we do is we have 5x squared minus 3x plus 4 plus 0 over the divisor of x minus 2. And that would be a final answer as well. I would take either one on the assessment. Really, again, I like this notation, but I don't know why in the hell my math lab puts it in this notation. So if you have questions, again, you got my email pretty late last night. Again, I got stuff all over my day that I can pretty much have to pick and choose the times I can get some things done. So that is the hardest thing to do, I believe, when dividing polynomials. Synthetic division is a beautiful thing, and it's nice to have it. All right, so if we were to divide this polynomial synthetically, so we call it synthetic division, okay? This is a key thing, that the divisor must be 1x minus c, which is a constant, meaning that the coefficient of x must be 1. Kind of like this guy right here, that coefficient was x minus 1. We're doing the same exact thing, same exact problem, but we're now going to do it synthetically. So how we do this is we set up this like little box here, and this box is going to be whatever the solution or the 0 would be for the denominator. So x minus 2 equals 0, right? So then that means x is equal to 2, okay? So really positive 2 goes in this box. Then some people start off with doing the coefficients first. We need to use just the coefficients of this polynomial. So we're going to list them in order. We have 5. We have negative 13. And make sure you have your calculators out, because we're going to have to multiply some stuff and add it and this, that, and the other. And then we're going to do positive 10 and negative 8. Okay, so you see we're just lining up the coefficients as was in the numerator. And then we're dividing it right here by the 0 of the denominator. Okay, so again, not negative 2, but positive 2. So it's always pretty much the opposite of what it really looks like, which we should know by now. When we were factoring and setting those factors equal to 0, we would just add or subtract it to the other side. All right, so then continuing on, we draw this little line here because we're going to do some stuff in between and down below. So the first thing we do is we drop down this 5. Okay? And then we do 2 times 5, which is equal to 10. And we put that there. And then we add these two things together. And if we add those two things together, negative 13 plus 10 is negative 3. And then we kind of do the same thing. I'll switch up a color here. Then we would do negative 2 times negative 3, which would be negative 6. And then add those guys. 10 plus a negative 6 is a positive 4. And then again, finally, we got to do negative 2 times 4, which is positive 8. I was about to add another color here. Okay, and we add those together and our answer would end up being 0 here. And then I always kind of like throw this little guy like at the end in its own box because that's our remainder. Okay. Now you're like, well, we just have numbers. How do we make this into a polynomial, right? How do we write this answer out? So in the homework tonight, it's going to say, what is your quotient, which would be the answer we find first, and then what is your remainder, which is we see here is 0. So how do we know what coefficients to put with these guys? Well, our original one right here is x to the third. Okay, so this was x to the third, this was x squared, this was x, and then this was our constant. All right, so if this was x to the third, this guy right here has to be x to the second. So that's x to the second minus, keep going, 3x, just decreasing our degree, and then plus 4. So they'll write it as maybe the quotient is like q of x, because quotient is q of x, and then r of x is equal to 0. Something along those lines. Or they might just like, I can't really remember exactly how they had it, but you get the gist that this is our quotient and this is our remainder. So quotient, and this is our remainder. Okay, so we're going to try another one. This one is a little bit different. The only reason why it's different from the guy up here is because this one had every variable exponent like decreasing, if that makes sense. So we have x to the third, x to the second, x to the first, and then constant. But here we don't. So in that case, we're going to have to put some placeholders. But we're going to do the same idea. Some people really like to just start off with doing, how did I do this before? We did it in blue. Okay. So some people like to start off by just writing these things out. Or some people like to start off by, all right, I'm going to put my little box here. What would the 0 be of this? It would be -3. And then I'm going to put the coefficients of this guy next to it. So I have 2. That's x to the third. And then I have +7. But I don't have an x. So I must put a 0 in that spot. And then -5. Okay. So I'm going to draw this little line here, and we're going to go about it like we just did, which some of you might be like, all right, I got that from last time. Let's get at it. So the 2 drops down. Then I got my -3 times 2, which is -6. Excuse me. I add those. That is a -1. I'm sorry, +1. So then we need to do +1 times the 3, -3, and that is -3. We add those, we get -3, and then we have -3 times -3, right? So again, I'm taking this guy and multiplying it by my divisor, and that is a +6. And then I add those, and I get 1. Let me put that in white. And then again, with my pencil, I know I have my colors. I always box that off because I know that's going to be my remainder. So even though our original polynomial didn't have an x, that doesn't mean anything for our numbers down here. Okay, so again, I started with the x to the third, x squared, x, and then a constant. So because this was x to the third, this guy is going to be x squared. So I'd have 2x squared plus 1x minus 3. So that is our quotient with a remainder of 1. So if you remember back in grade school, we put like R1, right? So in tonight's homework, it'll say the remainder is, and then you'll just put 1. And I'll rewrite that out with the whole word. Okay? Not so bad, right? Not so bad. Synthetic division, I always use synthetic division. Even though we have this rule, there is an exception that sometimes works out, but it's not easy. We typically, I will always give it to you where it is 1. That coefficient of the divisor is 1. I felt like I put enough space here, and I guess I haven't. All right, so the next question here. Determine whether x plus 1 and x minus 3 are factors of the polynomial. Blah, 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 blah. So we know how to factor this guy, right? We typically would use grouping, but that doesn't work in this case because really, if I try to group, it doesn't work out. It just doesn't work out. So are they factors? We'll be able to figure out if they're factors if, and I think that is, if the remainder is 0. That's if we know they're factors. So we're going to do 2 separate ones. We're going to synthetically divide 2 separate times. I'll write that in after. So let's start off with this guy right here. So I know I'm going to have -1. The 0 of x plus 1 is -1. And then I need to write my coefficients. Very nice. I have all the x variables decreasing exponential order. So I have 1 because that's 1x cubed. 2, -5, -6. And then I do this little guy. Excuse me. I drop down the 1. So I'm not going to use my colors. We should hopefully be in the understanding of what happens now. I do 1 times -1, which is -1. And then I add those. So 2 plus -1 is 1. And then I do 1 times -1, which is -1. And -5 plus a -1 is a -6. And then -6 times -1 is +6. That is 0. So in fact, because remainder is 0, x plus 1 is a factor. So it's kind of as easy as that. And what we could do eventually is we could divide this, and look, what did we get? We got this guy right here, right? And that becomes a quadratic that we'll be able to then factor a little bit more and find our other 2 zeros. That's going to be more of next time. I decided too much for the first day back. Okay? All right, so let's see if x minus 3 is a factor. So -3 is in my little box here. I'm going to put my coefficients. Drop my line. Drop my 1. And then go for it. I'll let you go for it, and then we'll check back here in a second. Oh, shoot. What did I do here? This should have been positive. Sorry, ladies. Some of you might have caught it and went about it. Perfect. I love it. All right, real fast. But in fact, the remainder is 24. So because remainder is not 0, x minus 3 is not a factor. These might be like yes or no questions on for my math lab. If I ever mix my math lab and formative up, I think you know what I'm actually talking about. Okay? So those are factors. Now we're going to do it the same way, though. Use synthetic division to determine whether the numbers are zeros of the polynomial function. So they give us the zeros. That's kind of nice. Same idea as we just did. Have to synthetically divide, and if the remainder is 0, then it is a 0. And then we go into the remainder theorem, which is next, to kind of connect what that actually means. So let's go ahead and do our synthetic division here. Because they're already zeros, yes, I'm going to use a -3. Okay, not positive 3 because it's not a factor. So we have 1, 4, 3, -5, -3. So this is a little bit a longer one. It's a quartic function. So drop the 1. 1 times -3 is -3. 4 plus -3 is 1. 1 times -3 is -3. Okay, that's 0. 0 times -3 is 0. Then this is -5. And then -5 times -3 is 15. And -3 plus 15 is positive 12. So, no. No. -3 is not a 0. And that's solely because of this. Our remainder is not 0. Okay. All right. Let's do the next one. So you see, the synthetic division is so much easier than that long division silliness. Okay, so I'm not saying it out loud what I'm doing. I hope that we're kind of all developing the habit, or not the habit, but just the process of what we're doing, right? Drop the first number, multiply, bring that that product up here, add, then multiply again, bring the product up underneath, add again, multiply, bring that product, add, multiply, bring that product here, and that is 0. So, because the remainder is 0, yes, 1 is a 0 of the polynomial. If that kind of makes sense. If the remainder is 0, it is a 0 of the polynomial. Okay? So that brings me into my the remainder theorem. If the polynomial f of x is divided by x minus c, kind of like we did in the second problem, the remainders r is, so r would be our remainder, so our remainder 0 here, is equal to f of c. So what that means is, I'll just kind of like put it back up here. What does that mean for this problem up here is that f of 1 would have been 0. Because c was 1, right? Because it would have been x minus 1 there. And the remainder was 0, which is this guy. All right, so we'll see that example kind of right here, and I'll write out exactly what I mean by that. So this would have been f of 1 would have been 0. Okay. So what do I do? How can I figure out if basically this is what it's asking when I say example here, is we are going to figure out, we're going to divide these and figure out f of 2, what does that equal? So it's basically saying, the question here is f of positive 2 equals what? Right? Because the 0 here is 2. So f of 2 equals what? Well, let's synthetically divide. We have 2 inside of our box up here. Then we write out the coefficients. This isn't the same one as above, right? No, okay. Still is 4x cubed. Okay. So then we have 4, negative 3, 1, 7. And then start synthetically dividing. Bring down the 4. 4 times 2 is 8. We add those. Negative 3 plus 8 is 5. 5 times 2 is 10. 1 plus 10 is 11. And 11 times 2 is 22. And 22 plus 7 is 29. So when I said you needed your calculator earlier, I've been doing all this stuff in my head. But if not, I swear there's a problem on here where there's some big numbers, but not quite sure at this moment. Okay, so what does this mean? I just said the question would ask, what is f of 2? And that is 29. And that's pretty much all you have to do. So if I plugged in 2 to this polynomial, it would equal 29. Kind of nice, right? Again, like an inverted way of how we've been doing things all of algebra. We just plug in 2 and then, throw it into our calculator, and it spits out 29. All right, so here, this is our final one. Given that f of x is equal to 2, blah, 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 find f of 10. Okay, so f of 10 means that's going to be what goes inside of here. And then I'm going to do 2, -3, 1, -2, 1, -8. So yes, that's a lot of numbers, but same process. There's nothing different about it. So let's go ahead and start synthetically. I think this might be the big number 1. So we bring a 2 down here. 2 times 10 is 20. Then we have positive 17. Yeah, this is where it gets big. So 17 times 10 is 170. 1 plus 170 is 171. And so you see, you definitely want to leave some space between because you don't want to get all weirded out there. So 171, yeah, I almost have to erase my stuff because my numbers are going to be so big. Let me erase and put these a little bit further apart. Okay. 171 times 10 is 1,710. And then pretty much -2. That's 1708. Or I'm sorry, 1708, 1708. 1708 times 10. Which is weird because that's 17,000. Hold on one second. Did I do something wrong? No, I think I got this right. So we got times 10 would be 17,080. And we add 1, 17,080. Times 10. Oh, not 080, 081. And if we times that by 10, that's 170,810. And then if we subtract 8 from that, or 8 plus that, that's 1,700 or 170,802. I'm going to check it real fast and plug 10 in because I feel like that was too big. I thought my answer was just going to be in the thousands, but I'm going to check it real fast. So we got 10, store. Okay, so. And again, this would just be plugging it in. No, that's right. So, yeah, big number. Didn't really mean to make it a big number. I just took it as another example that I've had before, or even close to ones on your homework might have some higher numbers. So I also just want to clear, so what is f of 10? Let me finalize my answer here. Codes. F of 10 is 170,802. Okay? You're going to have some questions, like maybe there's going to be a question, is x minus 8, a factor of x, x to the 4th minus, 512, something like that. While setting this up synthetically, with a 0 here would be 8. So I put 8 there, put my little backwards L, or put it in a box. And then I got 1. And then I do have, that's x to the 4th. X to the 3rd is 0. X to the 2nd is 0. X to the 1st is 0. And then negative 512. Okay? So you see how that goes? You have to put those placeholders. We really only had one prime example where we had to put a 0 in, and that was the first synthetic division one that we had. Okay? So make sure you're putting the placeholders for the variables that have the power of 0. Okay? Even though they're not there technically, to synthetically divide, we got to put something there for synthetic division to actually work. All right? And I'm just going to do it for the fun of it. Let's see. So 8. So 8 times 8 is 64. 64 times 8 is 512. Yeah, no, it won't work out. So, okay? I think that is it. Again, if you got my email, I hope you read my email. It's also an announcement on Canvas. I tentatively, again, should be back on January 17th. I know you guys miss me so much. I'm joking. But you do have a sub, just because I know some of you, if I was coming back the next day or I didn't have anything for you to really do, I would let you just kick it. But I want to make sure that you're actually getting your work done. So forgive me, but you kind of have to have a sub so you're working on your lesson stuff in class and your homework in class as well, right? You really don't want to have to do it outside of class. Let's finish this senior year really strong. I'm excited for it, and look forward to seeing you all the next time. And you'll have another lesson on Tuesday. Have a good day.